Hello, welcome. I'm sharing my screen. Everything's good. Okay, perfect. All right, so I wanted to explain binary search uh, with I have a code right now right there, so you can like know the code, right? But I have this book right here, the Algorithm Design Manual, and I have this book to provide an example of how to think about binary search. So binary search, like you can think of it as right here. Let's read the problem first. You're given a sorted array in ascending order. I'm going to draw some parallels right now. We have this book, right? The pages, it has numbers in the corner, the top left and right corner, top left corner, top right corner. And these pages are also sorted in ascending order, right? When we flip through the book, right? From front to back. Okay, and we're given an integer array of nums of n elements and a target value. So now let's say that we have this book right here, right? This book has, let's say, 800 pages, right? And let's say that we want to go to page 500, right? In this book. How can we like apply binary search to like opening this book? So let's say that there are 800 pages, right? And I want to get to page 500. What would I do? Would I open the book near the beginning? No, I wouldn't. Would I open the book like towards the end more? Like, yeah, I would, right? But that's like not really how the algorithm's gonna work. Instead, what we're gonna do is like if we want to like no, we want to we want to get to page like 500, right? 800 pages. What are we gonna do? We're gonna open the book, split right down the middle to page 400, right? Because we're kind of like guesstimating, like, oh, like how can we get to page 500? Okay, now we're on page 400, right? But we want to get to page 500. And let's say, like right here, we calculate the mid, right? And right here we have left, which is the lowest index, and right, which is the highest index. What can we think of that as? Well, this book has one cover, the front cover, and has another cover, the back cover. So our lowest index and our highest index in our array, for example, like right here, this right here, this lower index and this higher index, we can think of those right there as like the front cover and the back cover of our book. So I'm literally grabbing this book by both the front cover, the back cover, right? Like these two right here. I'm opening up, split right down the middle. I opened right down the middle and I'm on page 400, right? So while left is less than or equals, I'm going to explain some of this more on, but right now I'm just trying to get some basic intuition across. So we have mid equals left plus right, rounded down by 2, dividing by 2, but we're rounding down so that way we don't like have to do with decimals or anything. We just round down. So we're saying if array of mid is equal to the target, return mid. So if we end up on the page that we want to be on, which is our target, right? If our page value is equal to the target page value you want to be on, stop. Like we're just going to return that page number. Like we're going to see it, and then a reminder, like, okay, this is good. And now we're going to start reading, right? Because like that's how people open books. So I also did all these else ifs and stuff like that. I know I didn't have to do that, but I'm just trying to get a point across. So we can see each and every one of the individual cases of like how to think about this problem. So now we have, okay, so let's go back to the example now, right? We're on page 400 now, right? I want to get to page 500. So is our current page less than the target page? Yes, it is. So what do we want to do? Well, what we want to do is we want to narrow down our research, right? We want to flip a page, right? The computer does this. It flips a page, right? And now it's like, instead of like opening to the beginning side of the book now, we're going to be opening like towards the end side of the book now. We're going to want to get further closer to the end, right? So why does it do left equals mid plus 1? Well, because we already checked, right? The mid page, right? We're on our current page, and that current page was not the page that we're looking for. Therefore, there's no reason to really include it in our calculation. So we can like shorten the amount of information we're looking at by going to the next page. And now what are we going to do? We're going to do the same exact thing again, right? We have this side of the book, we have our front cover, our current front cover, which is left equals mid plus 1, right? and now we have our back cover, right? Because left was our front cover, and then right was our back cover. So now we have like two new covers, like our new starting point, new end point. And what are we going to do? We're going to again do left plus right divided by 2, rounding down, right? So we're gonna like, we're on page, we had pages 400, we wanted to get page 500, right? But our right was still like the end cover of the book, so we're gonna do 400 plus 800 divided by 2, so we're gonna end up on page 600, right? So I like split my book in half, right? Bang, now I'm on page 600. Okay, I'm on 600 now, page 600 now. Is that our target page? No, it's not. We want to get to page 500, right? So now, is our current page less than our target page? No, it's not. We're actually above our target page, right? Is our current page greater than our target page? Is 600 greater than 500? Yes, it is, right? So because 600 is greater than 500, right? Before we're operating, right, with like, we made left equal mid plus 1, which was like page, I said before 400 plus 1, which would be like page 401. And now we have page 401 as our leftmost cover. And now we found a new mid between 400 and 800, which was 600. And 600 is actually too far. So because we're actually too far gone now past the point of our target page, what we're going to do now is we're going to say like, okay, I like this front cover, I have my middle, and I have my back cover. This back cover right here is, our middle is actually greater than the target, right? And our back cover is like all this information, all these numbers that are way past our middle, right? So if our middle is greater, if our middle number is greater, and the numbers between our middle cover and our back cover are all greater than our target page, we can eliminate all of this right here, right? All of the back cover. And now we're going to go and we're going to have a new back cover. And our new back cover is going to be this page right here minus 1, because this page, remember, it wasn't, the targets were going to exclude it. So now we're going to be right between pages 400 and 600, right? Then we can do, or excuse me, 401 and 601. And basically, we're just going to keep going down all the way until we get to our page. And that's how binary search works, right? Now, why is left is greater than equal to right? It's because we can get to the point where like our left cover and our right cover are both like one page. And if they're both that same page, right, then it's going to be, we're going to calculate our new mid there, right? Because you can't say left less than right, because then you could be possibly excluding one of the pages. You can try this out in code, but that's an explanation for that. And then why is it return -1? Because it says if the target exists, return its index, otherwise return -1. So if we get down to the case where the left index is equal to the right index, right? And like we get all the way down to that case, and we get like, we keep, like we have this book, right? Keep narrowing down, keep narrowing down, keep narrowing down. We get to like a single page, right? I'm on page 404 now. 404 is not the target, right? So our front cover and our right cover are both a single page. If our new front cover and our new left cover of a book does not contain, like, if the target is not 404, which is the page we're on, then what we're going to do is we're going to close this book and say the page we were looking for was not contained within our frontmost cover or our leftmost cover, even as we narrowed it down more and more, right? So the page we're looking for, our target page, is not in the book, and we're going to return -1. And so yeah, so that's how the code works. So yeah, just to go over it really quickly again, this is our leftmost cover, our rightmost cover of book, while left is less than or equal to right. And just to like explain on that condition again, it's like you can hone in on a page, right? Let's say you're looking for page 400. You can like you can be on page 400 from the leftmost side getting there, and you can also get there from the rightmost side. And that's why that's less than or equal to. Because if you have left less than right, let's say you wanted to get to like page 404 again, and like you wouldn't be able to like calculate it just because of how the math works. You can try that out and you can see that. So by like putting in different examples. So again, if array of mid is equal to the target, return mid. If we're on the page we're looking for. If the page that we landed on is less than the target, we're going to move our new cover closer to the target. If we're past our target, we're going to move our right cover closer to the target. And if it's not in the book, we return -1. And so I didn't type out the code for this one. I typed it out beforehand because I just thought that like binary search is pretty like simple. It's something a lot of people know already, but I think that just like really having that visual example there is really useful for like imagining how exactly the process works. So that is it for this video. Hope you guys enjoyed.